joining from our team.
प्रणय डीडी शर्मा आ रहे हैं कि नहीं?
सर डीडी शर्मा सर तो वहाँ फीडिंग के पास खड़े हैं तो अभी आ नहीं पाएंगे। सर कैसे हैं सर, फोन ही नहीं उठाते हो आप?
ठीक है, तो let us start then.
Yeah.
Yeah.
So, hello everyone. Thank you for joining today's session. Today we have Amit Kulshrestha from NTPC along with his team Pranay and Mr. Negiji. Anyone left? Pranay, can you introduce whosoever left from NTPC?
Mr. Binay Malik will be joining us soon. Currently, Mr. Amit sir is present. He is the general manager of Waste to Energy New Initiatives Department, and I am currently deployed as engineer in Waste to Energy. And Mr. Sangharsh Negi is also present with us. He is the manager of Waste to Energy. So now,
Thank you, Pranay. So I will like to directly come to the point and will directly ask participants from one by one to ask their queries regarding this. And as you know that the last date to submit final submission of your design is 10th of January. Before that, you can change n number of times, as our previous campaign state that when you apply to a certain time period, you can able to verify or you can able to give direct questions to the NTPC mentors and all. So may I know which team or would like to ask the question first, and the respected NTPC mentors can answer.
Hello, sir. Am I audible?
Yeah,
Yes.
Yeah. So this is Vishnu
yeah, Vishnu.
from Jaipur. I have some queries, sir.
Mhm.
Sir, my first question is like in the submission, we have to submit the calculation for percentage yield or like efficiency of the our design.
Mhm.
So, sir, in that part, I am little confused at how to calculate that efficiency. Can you, sir, please guide me?
Uh, First of all, welcome to all of you for and thanks for participating in this great initiative. Because this hackathon we have launched only for the purpose of encouraging the new designs in the field of this crop waste management, and so that they can this productive use of this crop waste can be made by converting into charcoal and for generation of the power, so renewable power. So thanks for taking part in that. So now about the question you are asking, that you need to submit the yield and other things, huh?
Right, sir.
So now the yield basically depends on how much material is reduced during this process. So for that you must be knowing that when you heat it in the absence of oxygen, the volatiles are released.
Right, sir.
So the quantity of volatile released will determine the yield, and the initial analysis of the material, how much is the volatile content in that, and then how much you are going to reduce it after torrefaction. So these two three things will determine the yield. Now the reduction in this basically volatile content, it also depends on the temperature at which you are exposing the material to, and for how much time you are exposing it to that temperature. So these two things are very critical in the design. So if you increase the temperature too much, most of the volatile will be evaporated, and also the gasification process will start.
Right, sir.
So maybe if you go beyond 300 or 350, you will be entering into gasification zone. So and if you are below 200, then your torrefaction itself will not start. The the volatile release rate will be very low. So ideally, I think that you have to determine yourself and read the literature about that and understand that at what temperature you will be subjecting your material to, and for how long duration, and how that if it is a batch process, then fine. Otherwise, how you are controlling the oxygen ingress and the continuous exposure of this material to that temperature. So all these things you have to take care. Further, if you when you are going to fabricate the design and then subject to it to the actual test, if there are some oxygen ingress, then you will find that some of the material will also oxidize. So that will increase the ash content. So whatever yield you would have calculated, you will find that the yield is less than that, because the volatile has been released. In addition to that, some of the carbon is also converted into carbon dioxide. Hmm?
Right,
So,
sir.
the oxygen, controlling the oxygen is also a crucial part of this. If you don't control it properly, then the yield will reduce as well as the calorific value will reduce. So, suppose your input material has 65% volatile content, and output you are keeping, say, volatile content you want to limit to 30%. So, how much is the loss? From 65%, from 65 gram in 100 gram to it has reduced to 35 grams.
30-gram loss is there.
So yeah, so this 30 gram loss will be there from 100 gram. So basically this will be around, if you are maintaining at these level, then it will be around 70% yield, provided there are no other losses. So
Right,
for
sir.
other losses also you may estimate some things. So you will find out that around 60% or 65% yield can be reasonable if you are able to control the oxygen.
Okay.
Or
Okay. Got it, sir.
output, for output value of output volatile content, the volatile content in the output material limiting to 30% or 35% in that range. If you reduce it further, then calorific value will further improve, but your yield will further reduce. So those optimizations you can see. I think below 30 is okay. The volatile content in the output material is okay. Hmm?
Okay.
Yeah.
Okay. Got it, sir. Thank you
Yeah,
very much, sir. I have some another question also.
yeah,
Sir, in the
Vishnu.
So,
design
before you ask
Yeah.
another question, let me ask,
yeah.
confirm from Sanket, how many teams we have?
So we got 13 team confirmation to join today's call. 13 teams, but there are more than teams which have joined today.
So
So
how many
after
teams
getting
have
one
joined?
by one question from each team, we'll come to know about the how much teams are present today.
So if because if we are allowing multiple questions from a single team, then the other teams may be missed out.
Yes, yes, that's why
That's
only
what
one question.
Hmm.
And that's why I'm setting the context and setting the rules for this discussion. And thank you, Amit ji, for setting the contest. And also, I like to, one team will get one chance of their questions, and also wait, because most of the queries in our previous experience, also, most of the queries are common. So it may be that your fellow partner going to ask that question and all, and not after completing each and every question from all the participants, then if time allows, we will ask again for your second question. Thank you, Vishnu. And I'd like
Okay, sir.
to call second team to, so this is Vishnu from Gramogen.
Right.
Any other, or
Okay,
you can raise the hand.
I'm Sandeep from Bhopal.
Sandeep, okay.
Actually, rules, it's there. One query is there that
Zoom meeting not responding.
we have to prepare a working model. So I mean, we have to design something and then we have to test it, and then the results based on that we have to produce in the document.
Can you repeat your query?
And little
Yeah,
louder, Sandeep.
actually, there is one clause in the terms and condition that we have to prepare, I mean, fabricate and working model,
Hmm.
and based on that, we have to prepare some videos or documents related to that, and we have to upload it in the system. So after,
I think this at the first step you don't need to submit any fabricated model, but if you have, it is an
okay,
added advantage. Okay.
okay.
Hmm.
And one more thing, uh, the emission of the system.
Hmm.
So it should be only as a part of CO2 equivalent, or we have to take care all the GHGs and other gases like NOx and
No.
SOx and other things.
Whenever you are burning something,
Mhm.
you should meet all the environment criteria like SOx, NOx, any other volatile gases or whatever. Nothing should go out from the system, and if it is going out, then it should be within permissible limit.
Okay, and one more thing, sir, suppose we are doing for torrefaction or charring, pyrolysis, that in that case, all these gases will be coming out. So, should we compare the emission with open burning, or it should be only the permission limit thing? Because open burning will have much more emission than what we are targeting.
No. This is not comparing with open burning. The MOF criteria you will find out on their website for any waste to energy plant. So there are
Okay,
10, 11 emittents. Those
okay,
all of them should be within restricted limit.
okay. That's all, sir. Thank you.
So SOx, NOx, acid fumes, volatile content, and all those things should be within limit. Hmm?
Okay, sir.
So
I got
if
it.
you are making a design, then you should ensure that particulate or matter also doesn't go into the atmosphere, because this is agro residue. So some of the things will be in control because of the type of residue which you
What
are
is residue we are
using.
handling? Yes.
So the suppose this doesn't have chlorine, so you won't
Yes.
get hydrochloric acids.
Mhm.
So, if suppose the material doesn't have sulfur, then you don't get sulfur SOx emissions. NOx emissions could be there because thermal NOx can be generated. Even
Thermal
the
gas.
nitrogen in the material can
Material will also
give
contribute.
rise
I
to
mean,
the NOx.
yes,
Then,
sir. Yes, sir.
then those NOx limits, you should ensure that they are within control,
Permission limit control.
within
Okay.
permissible limit. So the that depends upon the firing. So you should ensure that enough oxygen is available. Sorry, the oxygen is not available in that quantity that oxidizing atmosphere is there, so that the nitrogen itself is getting oxidized. So maybe partially reducing environment is there. So you may in the combustion zone, but later on, if you don't provide enough oxygen, then what happens that you then the unburnt gases will be there. So unburnt carbon will be there, then soot will be there in the atmosphere. So you should provide some overfire oxygen also, overfire air after the combustion zone, so that that is neutralized. So all those things you should ensure that SOx, NOx, or any other harmful gases, they are not there in this
Permission, yes, yes.
emission as the emissions. Huh? Okay.
Okay. Yes, sir. Sir, last one last question.
So,
And
sorry,
how?
Sandeep. Sorry to
Okay.
interrupt, because after we
Thank you.
okay, yeah, thank you. And before moving to Abhishek, uh, what you guys have to do is turn on your video, because it's very essential for engaging an interactive session, and also for our social media engagement and all. Requesting all to turn on your video, and let's go to Abhishek. Abhishek, your question. Little louder, Abhishek. No, your voice is very low. You're audible, but can you little louder? No, no, no. Yes, yes. So I request you to rejoin. Meanwhile, we can take another question from another team. Yeah. Thank you, Abhishek, for cooperating. Yes, yes, you can speak.
Sir, this
Kiran
is
Mani.
Kiran Mani, sir. Yes, sir.
Yeah.
Sir, I have a small query that this was mentioned like agricultural mixed agricultural residue, right? We have done the laboratory experiments in CSIR IICT Hyderabad using only rice husk, sir.
Okay.
So here they mentioned like mixed agricultural residue. So it depends. Rice is, for example, if you take a rice straw bulk density is different, husk is different, stalk is different. So the torrefication chamber, what I am designing, it solely depends mainly on the volume, how much it occupies.
Yes, yes.
Suppose if you take husk, it doesn't occupy as much as volume as compared to a rice straw or some stalks or the leftover agricultural residue. So what particular residue are we using in, is there any clarity in that, sir, so that the design can be so apt to construct?
Yeah, thanks for this question, because yes, this is a very pertinent point you have raised, because the context of this hackathon was to eliminate the rice straw burning problem from Punjab, Haryana region. So therefore, we would advise you to design the system for this 550, the 100 kg or whatever you are designing, considering
Yes.
the rice straw.
So what I have done is I have taken like a husk, I have taken the straw, I have taken the individual bulk densities of the residues, and I have taken the average of it, and as of now I have calculated the volume based on the average bulk density only, sir. I think is that fine, sir, or should I
No, you can
make
revise it with the rice
with a
straw.
straw?
Again, this also depends on you, that maybe some designer may I would suggest that I will first pelletize the material, then I will torrefy. Another may
Yeah.
think that I will directly feed the loose material in the shredded form. So
Yeah, sir. In this, when you are using a straw form, it has to be shredded at least to some extent, sir, so
yeah,
that it
yeah.
definitely occupies the
And
given
some
volume.
of other designer may still think that if he can feed 20 kg bales, so that will give him optimum performance. So all this design on
Yes,
all these design
yes, I
conditions
am.
depend on you.
Yes,
Hmm.
sir.
So
I already
whatever
have done it
material
in
form,
laboratory scale.
yeah.
Sir.
So whatever material form you are going to use, you should keep the design accordingly. Hmm?
Yes, sir. Yes, sir. Okay, sir.
Okay.
Fine, sir. Thank you, sir. From my
Good
Another
afternoon, Amit sir.
Yeah, good afternoon.
Sir, this is Sushant Pramanik.
Okay.
Sir, I want to know one
कहाँ
particular thing.
कहाँ से हैं आप?
Sir, मैं NIT Durgapur, West Bengal.
Okay, okay. So you are a professor there?
Yes, academic.
Okay. Mhm.
So, sir, this and that particular concept, it has been told that you have to replace coal,
Yeah.
right, sir?
Yes.
So this briquettes
Yes.
or this compacted units,
Hmm.
okay, or this compacted units,
Hmm.
can we just use instead of coal in your in the burning unit, or
Yes,
you have
yes.
to think something else?
Yeah, no. We will be replacing some part of the coal with this.
Yes, sir.
Hmm.
You will be replacing some part of the coal with this.
Yes.
And another point is when you burn coal, when you burn coal in your power plant,
Hmm.
the coal ash, the residue, and we have all sorts of uses for that. We have worked on that. There's another part, these remnants, we have to talk about that also, that what will happen to these residues that is accumulates in the incinerator.
You are talking about when you burn this torrefied material into our
Yes,
boiler.
sir.
You have
Yes,
to
sir.
tell about that also.
Yes, sir.
I don't think so, because the
Okay.
first step is that you have to make the torrefied charcoal based on this agro residues. The
Hmm.
second step is that which is right now we are researching in our at our end. So that how much quantity, considering the ash quality and other things, we can burn in our plant.
Yes, sir.
Suppose, for example, you have raised a very good point, but that is not in your scope
Okay.
right now, because these materials contain some alkalis.
Yes, sir.
Alkalis make the ash melting point very low.
Yes, sir.
And if you burn this material into a boiler, suppose plant boiler, the ash will melt and deposit on the heat transfer surfaces. We call it fouling or slagging.
Yes, sir.
So that reduce the heat transfer coefficient, and
Yes, sir.
the boiler performance deteriorates.
Yes, sir.
So to keep that into limit, we are right now thinking of mixing it beyond certain limits, maybe say 10% or 15% only, or 20%.
Yes, sir.
So beyond that limit, we expect that this alkaline ash will not pose any threat.
Yes, sir. Because that is
So
the greatest problem for you.
so that we are going to control by blending ratio. So right now you don't have to worry about that. But in future, if we want to increase the blending ratio, we may think of eliminating the alkaline content also from this material
Yes,
by
sir.
simply washing or some other methods. So
When I,
right now you are not expected to do all that.
okay. And sir, one more point.
Hmm.
Just this one point is a piping and instrumentation diagram.
Yeah,
Piping and instrumentation diagram.
yeah.
So we ours is in a very tender stage. Okay. So this, how do I provide this? Because we have not built up the setup and also
No, we are right now only asking for the designs,
briquette.
not the actual models.
Yes, sir.
So
Okay.
even if you have tender your system in tender stage, you might have designed it.
Yes, but the piping and instrumentation we have not talked about. We have talked about the system. How will it work and how will it produce torified material?
So all these system must have some material flows,
Yes, yes, sir.
instrumentation. So material flow requires pipings, gas
Okay.
flow, other things. So basically, piping and instrumentation diagram is called P and ID diagram in
Yes, sir.
short. And
Uh,
these P and ID diagrams are basically the process flow with the proper instrumentation which is required for functioning of the system. So,
okay, sir.
hmm,
Okay,
so
sir.
that you may submit.
Okay, sir.
Yeah. So
Hi,
those
Thank you, sir, very
piping
much.
may not require this in this P and ID diagram. You might not require to submit the pipe thickness or this
Uh,
only schematic and the
uh,
attached instrumentation.
okay, sir.
So,
Hi, this is Professor.
but piping dimensions and other things, those will be required in separate section where we have asked you to submit the bill of quantities.
Right, sir.
Hmm.
Hi, this
Thanks a
is
lot, sir.
Professor Senthil Murugan from IIT Guwahati.
Yeah, namaste.
Actually, one of my PhD student, Arun Kumar and Muniraj, they have already developed a prototype, and then we have also demonstrated charcoal, producing natural draft concept, where
Yeah.
we don't need any electrical power, we don't need any, other sources of energy. So we use the own, let's say, if you have any biomass, that same biomass is used to generate the heat, and it will produce its own charcoal.
Okay.
And we have also optimized the design, and then we are able to achieve a desired quality of a charcoal, which is used for typically for a boilers and also for a water purification applications.
Mhm.
So now this is like, we did it in a prototype and we have demonstrated in down south in Tamil Nadu with a fixed structures, and the cost of the system will be not more than 1 lakh rupees. The whole component will be less than 1 lakh rupees. But in this case, we are planning to have something like a portable system where we will fix it in the tractor, and it can go to the respective field, and then it can stop in that field, and then they can cultivate whatever you have a biomass and load them in that one day, and then it will produce a charcoal, and then it can go to the multiple locations and produce the charcoal.
Yes.
So this is a kind of a system which we are thinking about treating locally and producing a charcoal and minimizing the CO2 emission. So, and also we have come up with the approach how we can minimize the particulate matter, particularly that is a critical component in Delhi and Haryana area. So we have come up with some filter mechanisms where they will be removing all this particulate matter, and that can be brought back to the ground again. So we have done prototype, and then we have also demonstrated as part of the, let's say, MNRE project to common people, and people are also taking up. Now, if we want to take this into as a tractor mode, we have not done the prototype, let's say moving object. This is something new we are talking about here. So what do you think? Is that something you want to have a fixed system is more usable, or you think that, it is portable, it can move along the field?
What is the expected capacity of this?
It can be, it can go from, let's say, 100 kgs loading to up to 1 ton loading. We can load,
Is it batch process?
Yeah, it's a batch process. It will take 6 hours.
So 6 hours. So in a day, you will process 2 batches or what?
See, it is up to us, we can continue 3 batches also per day.
Okay, so 3 to 4 batches you can continue. So 100 kg into 4, so 400 kgs, or 1 ton if you are designing, then 4 tons.
4 tons we can do the processing per day.
Okay.
And this is like a modular structure. Anybody can carry in the tractor.
Okay, so what will be the cost of this?
So typically, for Arun, are you in the line?
Yes, sir. I'm in the line, sir.
Can you?
Yes, sir. The cost of this pilot scale plant we developed around 75,000, sir, with the steel, with the installation, proper installation process.
Okay. So basically, the question that you have asked is whether this portable would be useful or not. The answer is that if the average land holding in Punjab, Haryana is around 3 acres. So in 3 acres, you get around 6 tons.
Okay.
So 6 tons of agro residue, 6 to 7 tons agro residue, now farmer has to torrefy himself. So how much time he will take in torrefying that, and then if the machine is available for other users or not. So if for suppose in a village you have 4-5 machines, so then if it can cover all the village and consume all the agro residue of the village, then the portable makes sense.
Yeah, that's the plan. That's the plan we were thinking about. Let's say per village, let's say you give 5-6
solution. So another solution is that you have this kind of machine at one place in a village. Make it a atta chakki type of model. Everybody comes there, takes a token from you, and at a predetermined dates comes there, torrefies his material, takes it back, give you some conversion charges, and sells it to NTPC. So
that's what the whole idea is, that we were working with the Vedanta. So the Vedanta has come forward asking us, do you have any technology where we would like to deploy across Punjab? So where we would like to lease the technology to the agricultural field owners, and they will be selling the coal to some third party, and they will be paying rental to this, let's say, a tractor, basically. It's basically another cultivation unit.
So both the type of models are feasible. You have to find out your own cost economics, which would be better, stationary or the movable. So the choice is yours.
Okay, but
all it depends on how you pitch your model as a techno-economic case.
Okay, so then a question comes to me that NTPC is going to help us to give some support for demonstration, deployment, etc. in this case.
These 6 models which we are going to choose, we will be handholding them if we found them suitable.
Okay.
So it is not that every model out of those 6 will be given full handholding, but if we found them suitable, we can handhold them. Even beyond these 6 also, if we found some suitable models, handholding can be done there also.
Okay.
So, but all this depends on NTPC management, their perception about your case, and your the opinion of the judges, independent judges. So that will determine.
Okay.
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 So
Thank you.
yeah. So any other question, because I have to leave in 5 minutes. So if then my team will continue. So and if any other question is there, let me answer. Last
Abhishek,
question.
I think.
Hello, sir.
Yeah.
Yes, sir. My name is Shardul. I am from IIT Bhubaneswar, sir. And I have a team here, Neha ma'am, Mohit sir also. So I have some couple of questions regarding the design. So for the design, like how much in detail we should design the process. So like here we are trying to accommodate the microwave process, microwave heating mechanism into the torrefaction. We wanted to do this. So, but in designing, like how much in detail we should go into it.
So you should go into the exact the extent of detail where you will be able to give the manufacturing drawings and get the machine ready.
Okay,
So
okay.
it should be fully developed, full extent you should go. And then now, let me also ask you about this microwave process. So you are
Yes.
from which IIT?
IIT Bhubaneswar, sir.
IIT Bhubaneswar. So
Yes.
you might be knowing that this microwave process works on the this water molecule.
Dielectric heating, sir.
Yeah,
Yes, sir.
yeah. So water molecule should be there, so to heat this.
Yes,
So
yes, sir.
I would suggest you to first experiment also at a lab scales that it is getting torrefied, because what according to my feedbacks, it is this dried material, it is difficult to torrefy using microwaves.
Yes,
Hmm.
sir. True.
So
Sir,
you may need to add some additives in this,
yes, sir.
so that it is torrefied using microwaves. Hmm?
Yes, sir. Actually, for that, we have done the microwave heating for pyrolysis process on lab scale in our institute also. So yeah, it gives good results. And for this particular process, like as you have said, rice husk or rice straw or any other biomass, they don't have that much of like tan delta, that is absorptivity of the microwaves. So we
Yes.
need to add something. So like for that, we have innovated our model to go for integrated heating mechanism, like microwave heating also will be there and the convective heating also will be there. So like it can take it, like there will be a uniform heating throughout the particle.
Yeah.
So it can give more better results than
Yeah, yeah. That
simply heating and
theoretically,
even
yes,
just
it will be very
microwave
good.
heating.
Yeah, that is a
Yes.
good concept. So you are going to add some additive into this.
Yes, sir. We have planned and we have sent you the details. We have also given you the whole the process and recovery of that added material also. We are planning that
Yeah,
so that it won't be going into the torrefied biomass. So it would be a great.
Yeah. So that is a good idea, and this will also save a lot of energy because this
Yes,
material
sir.
is
The time
insulated.
is.
Thermal conductivity is bad. So if you are heating it from the outwards, the core remains untorrefied,
Yes, sir.
or you need lot of heat to be transferred to the core to make it fully torrefied.
Yes, sir.
So
Yes, sir.
you have the good concept. You can go ahead. So
Yes, sir.
any other questions?
Abhishek,
I
I
would
think he's
suggest that
joined back. Yeah.
Yeah, I'm audible now.
yeah.
Yeah. So my question is, there's mentioned that the desirable properties of the end product. What is the expectation with regards to the end product? I mean, the calorific value, energy density, grindability. There is any kind of specified thing that we need to follow, or it will depend on.
Normally, literature says that 25% or 20 to 25% is the GCV rise. Then grindability should be more than 50. And then what else? What you wanted?
Energy density, calorific value, and grindability.
So that I have already given you. The 25% should be the increase in energy in kilocalories per kg. So grindability more than 50.
Okay, and sir, one more question. You have mentioned that there should be a control mechanism to meet emission requirements. So there is that control mechanism. I need to just want you to elaborate upon that. What
if you envisage that particulate emissions can go into the atmosphere, then you should have the particulate control mechanism. If you envisage that some other gases which are toxic are going, then you should control them also. So it all depends on your process, how you are making it, and what are the pollutants, how you are controlling them. Okay.
Okay. With regards to flue gases also, sir,
anything from your plant which is going out, it should be within limits, within MOEF limits.
Okay. Thank you.
Okay. So thanks to all. Now I have another engagement. So my team will continue. If they are not able to solve your issues, they will write it down, note it down, and maybe I will ask them to reply in writing later on to you. If with my interaction, they will give those answers later on, and give it over email to you. Okay. And if they can right now solve your queries, that is fine. If not, then after discussion with me, they will solve your queries. Okay.
Yeah.
Thank you, sir.
Thank you, Miji.
Thank you.
Thank you, Miji. Now Pranay, Mr. Negi, and Binayak will continue.
I've done 4 things. Extended surface, you have to do that.
So Mr. Binay Malik is present here. He is our assistant general manager. He will take on from now and he will continue the meeting.
Binayji, you to go?
Tell me, sir.
Yeah. Any other question? So I can see there are a few teams. Quads is IICT Vijay team is present. They are not asked question. All sorted from your side. Any other questions, teams?
They are also 7 center, but length.
Samkitji, I have one question for you probably. In the submission part, there is only one option that we have to upload a PDF of around 20 MB.
Yes.
So if I want to put a video, then how would I do that?
So for video, what you can do is put that video in YouTube unlisted version.
Okay.
And that unlisted link you can put on the PDF itself.
Unlisted version of video in YouTube and then link to the PDF. Okay.
And link
or you
the
can
PDF.
add it in the Google Drive also, and you can share the Drive link.
Okay. That also can be done. Yes. Thank you.
Yeah. Thank you, Pranay.
And maybe if time is there, I can ask one more.
Yeah, absolutely.
For the NTPC team, actually, sorry. In case of the cost-effective design, I mean, if I'm working on a batch process, I mean, in a batch design with 100 kg per day capacity, I can multiply the number of batches, right? I mean, there is no thing that in one day I cannot go beyond two or one batch or something like that. Hello.
We can't get your question, sir. Can you please repeat it?
If I'm working on a batch model, then in the batch model, can I go for more than one batch per day?
Yeah, you can develop a modular system. You can place multiple lines of your equipment, and with that you can produce multiple batches. But
Okay, I mean, to meet
you
out
should keep
100
in
kg
mind
per
that,
day,
yeah,
to meet out 100 kg per day, I can go for multiple batches. I mean, what I'm asking.
yeah. If your single line is producing a single batch is less than 100 kg, then you can have multiple lines. But you
Okay,
have to
okay.
keep in mind the cost effectiveness of the process also.
I mean, suppose
Increasing the number of equipments would increase your final cost also.
okay,
That you have to keep in
suppose
mind.
it has a capacity of 50 kg per batch, and if two batches can be done per day, then it will meet out the requirement. That's what I was asking.
So I cannot answer you, like that only. You have to make the calculations, and you have to come up with the solution as per your design.
Okay, okay, okay.
That the cost should be optimized. Okay.
Yes, 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 yes. Thank you.
Anyone else? Samtiji, I
One
think
more.
no one else is.
No, one more question, if I can allow. Uh,
Okay.
Suppose the life of the total system. I have worked for last 2 3 years in pyrolysis and gasification, and there is always problems with deposition of tar and coke and clinkers on the chambers of gasifier and pyrolysis system. So it is very hard to determine that how long the equipment can go. Can you enlighten any idea about that? If I am working on a design for pyrolysis, that how much, I mean, how many batches or how many hours it can be operated? Because that will bring out the operation cost of the equipment.
Vinay sir, can you answer this?
I am not getting the question properly. Can you please
Okay,
repeat?
he's saying that
Suppose
what should be the the lifespan of the equipment. He's asking that he's designing. What should be the lifespan, tentative lifespan?
yes.
Pranay, have you mentioned anything about the lifespan of the equipment in the document?
Yes, sir.
Have you written anything about the expected life of the equipment?
No, sir. We have not mentioned about this, but we are. It would also be included in the scoring mechanism, that how long the equipment will be working for the participant for the entry.
So it will give the cost, no? It will add the cost. If
Yes, it
the
would
life.
add to the cost. That if one equipment is added and it, we have to change that equipment every 6 months, it would result to the increase in the effective cost.
Actually, that is what it is difficult to determine that how long the equipment can go.
Sir, you will
I
be
mean,
conducting the
sitting.
trials. You will come to know about the time period when up till when the tar deposition is controllable, and up to and beyond what you cannot control that.
Okay, okay, okay.
See,
Thank
we
you.
want this end product with a optimized cost.
Hmm.
So ultimately, your design, your system should meet the requirement.
Requirement, yes, yes.
Yeah,
Thank
we
you,
want the
thank you,
system to
Vinay
run.
ji and
We
Pranay
want the
ji.
system to run long term. but
Yes,
we
yes.
know that some situations are inevitable and some parts need to be changed.
Hmm.
So that you
Hmm.
have to design that which parts to be changed continuously, and which parts to be kept for the long run.
Yes, yes,
And there
yes,
are
yes.
several quality of materials are also available in the market. You have to judge upon that
Hmm.
to it would determine the initial capital expenditure, that how much would be the costing of your initial costing of your plant.
Okay, okay. And one more question. Can I submit designs in two categories, or I can only participate in a single category?
This would be answered by Mr. Samkit.
Yeah, can you repeat?
Can I submit designs in two categories? I mean, one more than one category.
I think this you can submit. I think the jury will consider maybe both or maybe either of one.
Okay, okay. I mean,
So most probably in our past experience when this thing happened, so
hmm.
jury will consider the best one.
Okay. I mean, I can submit in the both categories.
Yeah, but here is a problem. When you submit on our dashboard, there
Hmm.
is only one category to submit.
Category to select. Yes, yes, yes.
Yeah, yeah. So as of now, it is one category. For second category, let me again come back to you regarding while after discussing with the NTPC team and all.
Okay, okay, okay.
Yeah.
Thank you.
Hello, sir. Hello. Am I audible?
Yeah.
Yes, sir. I have the question regarding the economics of the this whole process design. So it goes like this: like we have to introduce the profits, like where the cost we will like be extracting out, and where we'll get the profit in terms of like business model. We can say like we can like we have to do it or not, like the economics of that this particular process.
Or no, ultimately, you have to think of the cost of the product, no?
Yes, sir. Yes, sir. That's what I am asking. Like,
Pranay?
like
Yes,
at the
uh,
beginning.
the cost of the product and the cost of operation also, sir.
Uh-huh.
Yes, yes.
So capital cost expenditure and the O&M and the maintenance, those things should be covered.
Means like what will be the cost at the end, like the product we are getting, the efficient product, and comparing it with the whole cost required for its capital investment or operation or everything required in it, and then comparing it and then checking whether it is in profits and losses. So like we have to do this whole analysis or not? Yeah, that was the question.
Yes, you have to do that, sir.
Okay, okay. And one more thing, like we have to mention like every material used. Like let's say we have one pipe for a gas, so like we have to use give the material for that pipe, or like everything related to that pipe, like and the reasonability for that.
For all the equipments that you are planning to include in your design, you have to give us the detailed drawings and the material of construction for all the equipments and pipings and all the process flow.
Okay, so like the whole detailed drawings and all, let's say a CAD drawing, so we have to attach it to this like 20
To the
MB
PDF
submission.
only. Yeah,
Okay.
you can bring down the resolution so that it can
Yeah.
be viewed properly. Just that it does not get pixelated, and you can add it in the PDF only.
Okay. Okay. Okay.
And
Thank you.
Shardul, regarding the
Yes.
20 MB thing, so you can
Hmm.
make your PDF as much, but you can convert or shrink it in various online software and all. You can use
Yes.
that
Yes.
part. And
Yeah. True.
again, yeah. So regarding the question that whether you can submit on the two category or not, I just spoke with Amit ji, and he said if your design of your machine is same, So you have to submit in only one category. For the next category, the technology should be different from your first category. So so in short, if you have different technologies for all the categories, you can submit. And regarding the technical part of submission, you have to again register. You have to again with your different ID and all, and that's why you have to follow that process.
Okay.
Okay, you can put your team name and then you can put one or two after your team name, and then your second category you can select with a different technology. If you have a same technology, then you have only you should go for only one category.
Okay, thank you.
Yeah. So regarding any technicalities regarding using the platform, using the hackathon design submission software, you have any query, Kaushik is also with us, and you all like please note Asgar's email ID also. You can have any queries. So I will put on chat itself. Yeah. Any other question regarding the submission thing, regarding the design, and please go through all the necessary options in the idea submission, and also go to the rules and terms and condition also. It's all available on your dashboard. In your dashboard there is a resource section also. We will keep updating the new videos, like today's videos also you can find in that particular resource section. So last question as per as time, anyone? Yep.
Sanket, I don't think any other questions.
Yeah.
Yeah. Okay, Samkit sir, let us close this.
Yeah. Okay. Thank you, Mr.
Thank you,
Binay sir.
thank you
Thank
all
you,
of
Sanjay
you
sir.
for giving queries of all our questions. Thanks a lot.
Thank
And
you. Thanks a
also
lot.
one more thing. So like this is NTPC doing first time. They're throwing this challenge, throwing this opportunity in the open market where you can where you can fight, where you can do the next level of innovation, and you can put everything, and they will help you. Like Amit ji has told you that you have not only come into top 6, whether they like your idea, they like your design, they like your team, that you can go to the further, apply or do this challenge if you want to do, if you go to that further, because you know the amount of waste in this country, and how, and it can be a very good, you can say, a startup, or you can say very good industry. So thank you all, and best of luck, all of you.